Hi there. In this video, I'm going to give you a quick introduction to point cloud data. What is it? So point cloud data is a type of data that is made up of a bunch of points. Each point has an XYZ coordinate as well as perhaps some descriptors about that point. So why would we use point cloud data? What is it good for? It's very good for storing irregularly spaced points, such as the ones derived from photogrammetry or LiDAR data. So this is as opposed to raster data, where we'll often be representing continuous data with, a bunch of regularly spaced pixels in a rectangle. Point cloud is maybe a little more versatile. It lets us locate these points wherever we want, and that is good because it's good for applications where you may be collecting irregular data. Here's an example of a photogrammetry image where we have correlation points at various places in the scene, but there's some points like in the shadow of the car here or on the side of the car where the image correlation didn't go very well, so we actually don't have many points located in those locations. And with point cloud data, that's fine. We're not obligated to fill in a pixel there. It's also a compact format that can typically hold millions or even billions of points for huge data sets. So how are point clouds displayed? They're usually rendered in some kind of 3D perspective, and the points are kind of located in that 3D space, and then they can be colored by some value. On the left is the surface of a teapot, where the points are simply colored by elevation or height in the z-axis. On the right is a scene of a bunch of buildings kind of in a forest, and we can see the points here are colored by their surface type. So building roofs are colored as orange, leaves are colored as green, and kind of grass or courtyard is colored in this off color. So that's another way to display point cloud data. How is it stored? There's a variety of different point cloud file formats that you might come across. They're roughly divided into ASCII versus binary. So ASCII formats are generally text-based. They're much larger file sizes. Each text character is stored with a 7-bit binary number, so that adds up over time. And typically in an ASCII file, each line of text is going to represent a single XYZ point, and you can open them in text editors. So here's an example of that. Just open up the ASCII file in a text editor. I think this was an XYZ, and you have 4 columns of data and a bunch of different rows where each row is a individual point. Binary formats are more complicated. They're not text-based. They're more compact, but they can be difficult to access. You can't just open them up in a text editor. And so the most common binary format is .las. And here's an example of that. This is what the file structure might look like. There's about 11 different LAS formats. And this is format 0. You can see we give XYZ, each get 4 bytes in the file. And there's a bunch of other information about this. In this case, it's LiDAR shots. The intensity, the return number, classification. So you can kind of structure these files so that each piece of information gets some number of bits. And it is possible to view LAS files, point by point, where each point gets a row, so you can still do that, but usually this requires a specialized GIS software. So that's a little bit about point clouds. Thanks for listening.